So this problem is going to pull together some skills we had from when we first introduced differential equations or our derivative to investigate local extrema. So that's where we were looking at the first derivative test and the second derivative test to figure out if we had a max or a min, right? And then it's also going to combine that with our solving differential equations skills that we've just developed, where we're using integration to find the particular solution. So let's go ahead and identify our differential equation, the equation for the derivative. So consider our differential equation, 3 minus x over y. So this is the same as saying f prime if we were to write it in our other notation, all right? But we're told that y equals f of x is the particular solution to the given differential equation on the interval x where x is between 1 and 5, such that the line y equals -2, so that value of y is going to become important, is tangent to the graph of f of x. So tangent is telling us that we've got our derivative equal to 0 at that point, right? Our tangent slope is 0. All right. Find the x-coordinate of the point of tangency and determine whether it's a local maximum, local minimum, or neither at this point. All right. So we are investigating whether or not this is going to be a local min, local max, or neither. Right. I should say that the tangency isn't telling us that the derivative is 0. The looking for if it's a local max or a local min is telling us we're looking at when the derivative is 0. That was sloppy of me to say that. All right, so we're going to use our differential equation. We know the y is -2, and we know that the slope has to be 0 at our point of tangency for it to be a max or a min. So I'm going to have -3 minus, positive 3 minus x over my new y value, -2, equal to 0. Solving that, we multiply both sides by -2. And you're going to get 3 minus x equals 0, or x equals 3. So my point of tangency is 3, -2. When we're looking to identify if it's a local max or a local min, we have two techniques for doing that. Right? We have the first derivative test and the second derivative test. The first derivative test is where we had our number line with our derivative, and we had values, right, on either side of that critical point. We run into a problem with this, though, because if I pick a value here, let's say I picked 2 as my value on this side, right? If I pick that as my value, then I'm going to have my derivative is equal to 3 minus 2 divided by y, or 1 over y. But I don't know anything about that value y, so I'm not able to determine what sign we have here, positive or negative. And the same will be true on the right-hand side of that point. So the first derivative test fails. We're not able to use that in this problem. So we have to actually use the second derivative test. That's our only option. So our derivative is our first derivative. 3 minus x divided by y. Our second derivative, when we write it in this notation, right, is written like this. At the point 3, -2, right, that's what we're investigating. Well, we're going to have to figure out what that derivative is before we can plug in the values. So our second derivative, we're thinking about, what do I have to do to find the derivative here? Well, you'll notice we've got a fraction, we've got a numerator and a denominator function. So this is going to be our quotient rule. Which says we've got the derivative of x times g minus f of x times g prime of x divided by g of x squared. All right, where our original function has f of x as the numerator and g of x as the denominator. So let's go ahead and find this derivative. So I've got f equals 3 minus x, my derivative of f, negative 1, g y is equal to y, g prime is equal to 1. So we substitute into our quotient rule. I've got the derivative, negative 1, times g, which is y, minus my original function, 3 minus x, times the derivative of g, which is 1, divided by g squared, so y squared. So we got negative y, distribute our negative, right? All right, so that's our second derivative. Now we have to find it at the point of tangency. So we go ahead and substitute in our values. So we got the opposite of negative 2, minus 3, plus 3, divided by negative 2 squared. All right, so we got 2, and then the 3's cancel, over 4, or 1/2. So a positive second derivative, what does that tell us about our original function? Well, that tells us our original function, y, or f of x, is concave up. At 3, negative 2. Therefore, the point is a local min. By the second derivative test. All right, then if you want to visualize that, we have our point of tangency, right? That line there is y equals 2, y equals negative 2, which is a horizontal line. That's how we got that slope of 0 initially, because it's a horizontal line, y equals 2. And then we've got concave up for our function, because the second derivative is positive. So our function has a relative min at the point 3, negative 2. All right, so that's A. Now we're going to look at B. So we're considering the same differential equation. Let's go ahead and read what we've got going on. Let y equal g of x. So we know our original function is going to be g of x. Be the particular solution to the differential equation. So to this guy up here. Particular solution. Particular solution tells us we are integrating and then finding the value of c. All right, on the interval negative 2 and 8 for x with the initial condition, g of 6 equals negative 4. So we're going to use that piece of information as well. Our first step when we're looking at a differential equation and trying to solve it, we have to separate our variables. So we multiply both sides by dx. And then we want the y to be on the other side. So multiply both sides by y. So we've got y dy equals 3 minus x dx. These cancel. And we integrate. So I end up with y squared over 2 equal to 3x minus x squared over 2 plus c. And we're given the point 6, negative 4. So we use that to find our particular solution. So I'm going to go ahead and substitute in that value. So I've got negative 4 squared over 2, go to 3 times x, so 6 minus 6 squared over 2 plus c. So negative 4 squared, 16. Guess I'll write it all out. I've got 18. So I've got 8 equals 18 minus 36 divided by 2 is also 18, right? Yeah. These cancel. C is 8. So let's go ahead and substitute in C. And we're not done yet because we want our equation to be y equals. So we have to multiply everything by 2. So I've got y squared equals 6x minus x squared plus 16. And then I do the square root, and I end up with my final answer. Y equals positive or negative square root. And if we rewrite it in our descending order, we don't know if this is a definitive answer for us yet because we've still got this plus or minus. So we need to think about that. Well, what's the point we began with? We began with the point 6, negative 4 as our condition, right? This negative here only occurs if we've got the negative out front. So our solution is going to be negative root negative x squared plus 6x plus 16. And that's all for this problem.